who missed class today, Monday, December 17th, these are the problems that we did in class, and I'd like you to pause the video, try the problem on your own, and then go ahead and see the solution. So I'll go ahead and start the solution, pause it if you're at home watching this. So the 12, the 35, and the 37, we need to see if that's a right triangle. So we write out the Pythagorean theorem, the formula, and that did not write out very well. Okay, a squared plus b squared equals c squared. What we do is we start by identifying c. C is the largest value in the set, and it's very important that you plug that in for c. The other two, it doesn't really matter whether they are a or b. And then all you do is you make sure that a squared plus b squared equals c squared. So 12 squared is 144. 35 squared gives you 1,225. And 37 squared gives you 1,369. When you add 144 and 1,225, you get 1,369. And the test tomorrow is going to ask you to do a problem similar to this, and you're going to have to also explain why it is a right triangle or why it is not a right triangle. So in this case, 12, 35, and 37, those lengths do make a right triangle, and you can just explain that in a right triangle, a squared plus b squared always equals c squared. So we went ahead and we made sure that a squared plus b squared equals c squared. And that is true, so we know that it is a right triangle, is a Pythagorean triple. So now we're ready for number 2. In number 2, the problem has this picture, and they want to know if this is a right triangle. So what I'm coloring in is that a right triangle. And to figure that out, again, you do a squared plus b squared equals c squared. What is different about this problem is you'll notice that these are units squared. So they actually went ahead and took, for example, the side length of 12, and they squared it already to get the 144. Over here, the side length of 11, they already squared it to get the area of 121 centimeters squared. And over here, the side length of 5, they squared it to get the 25. So when you're identifying each piece, the largest piece is c squared. So this is 144. And I don't need to square it because it's already been squared. The 144 is not c, it is c squared. Then b is 121. B squared is 121. B is actually just 11. And then finally, a squared is 25. So we take the 25 and we add it to the 121, and we get 146. And that is not equal to 144. So these two, the areas, have to equal the area over here. And they are not equal, so this is not a right triangle. Number 3, we have a problem just like the one you just saw. And we're going to fill in a squared plus b squared equals c squared. And again, the units are squared, so these are already squared. They are areas. So I just plug in the largest value. I plug in for c squared. Then I'm going to plug in 441 for b squared. And then for a squared, I'm going to plug in 400. 400 plus a 441 gives you 841. And a squared plus b squared does equal c squared. So this is a right triangle. Now let's look at number 4. Number 4, the question asks, which of the following is a right triangle? So we need to, for A, B, and C, use the Pythagorean theorem formula to figure out if it is a right triangle. The most important thing to identify is the largest value c. As long as c is over here, a and b are interchangeable. So make sure I identify the largest value and put it in as C. So 9 squared, we get 81. 41 squared is 1,681. And 42 squared gives you 1,764. Now we're going to add 81 and 1,681, and you get 1,762. Although it's close to 1,764, they are not equal, so this is not a right triangle, that first one. Let's do the second example. So B, in B, C is 28, so I'm going to plug that in first. The largest value is going to be C, and then 20 squared we'll put in for A squared, and we'll put in the 22 for B. 20 squared gives you 400. 22 squared gives you 484. And 28 squared equals 784. Together, 444 equal 884. And that is not equal to 784. So this is not a right triangle either. So then we would think that probably this last one is going to be a right triangle, but we want to make sure that we didn't make a mistake earlier. Again, identify the largest length and put it in for C. And then the other two you can put in for A and B. So A will make 35. And B will make 612. So 35 squared, you get 1,225. 612 squared, you get 374,544. And 613 squared gives you 375,769. When you add together 1,225 and 374,544, you get 375,769, and that equals what 613 squared equals. So we know that this is a right triangle. So the answer to this problem is C. Okay, let's look at number 5. Number 5, we have to find the missing side length. So once again, you write out your formula. And the first thing you want to do is you want to identify C. C is always the longest side. It's across from the right angle. And in this case, we need to find C. We don't have C. Now we're going to identify A and B. So A, we're going to say is 2. And B is the 2 square root of 5 squared. 2 squared is 4. And then over here, power to a group you distribute. So the 2 goes to the 2. The 2 goes to the square root of 5. 2 squared is 4. And if you remember what we talked about before, the inverse operations are squaring and taking the square root. So we get just a 5. They cancel each other out because they're inverse operations of each other. And we get 4 plus 20 equals C squared. So 24 equals C squared. The last step here is to take the square root of each side. And the square root of 24 is 4.9 approximately. So that's what C equals, is 4.9. And in a calculator, if you were going to put this 2 square root of 5 in, this is what you would want to type. You would want to type in 2 square root of 5 and then press enter. And you would see on your screen 4.472135955. Then you press the caret symbol. When you press the caret symbol, automatically on your calculator it will say ANS, which stands for answer, with your caret, and then you press a 2, and that's going to square it, and you'll get a result when you press enter of 20. So you can also do this on your calculator. And this is all we have time for right now. There's one more problem that I'll do on another video that we did in class today.